You're stranded on a desert island. You're about to be rescued, but you don't have a calculator, and the only way that you can possibly get to the mainland is finding the approximate value of the cubed root of 8.1. Okay, that's never going to happen, but I'm going to show you how to approximate it anyway. So this is a problem that can look kind of frustrating when you first see it because there's no scaffolding, there's no hint of what you can do based on your knowledge of calculus so far. But this is a problem that goes with linear approximation. And so the way that I'm going to bring calculus into it is that this suggests to me that this might be the value of a function that I kind of understand. And so this is going to be f of 8.1, where my function f, I could invent 100 functions that have this value at the point 8.1, but a very natural one to think about is f of x is equal to, let's say, the cubed root of x. You could write cubed root, or you could write x to the 1/3. They both mean the same. So f of 8.1 is the cubed root. And I want to use linear approximation, and there's two formulas in that section on linear approximation. The one I'm going to focus on is that the change in f is approximately equal to the derivative at the point a times the change in x. So whenever you have a problem that asks you to approximate something, a great bet is to use that approximation formula, the one with the squiggly lines. So what do these things mean? You have to select an x value, you have to select a value for a. So your value for a, you want to choose that to be the simplest thing that you can, because that's the thing you're going to have to actually compute. So in this case, I want to take a equals to 8. I'm going to take x equals 8.1, and so delta x equals 8.1 minus 8 equals 1/10 or 0.1, and then delta f equals, well, it's equal to f of 8.1. That's what we want to approximate, minus the cubed root of 8. So the cubed root of 8 is equal to 2. And so this gives me a strategy for doing this problem, because if I know the left-hand side, or if I know how to approximate the left-hand side by calculating the derivative and multiplying it by 1/10, then that's going to give me an approximate value for the cubed root of 8.1. That's exactly what we're going to do. So in order to do this, I'm going to take the derivative of f and then plug in 8 into that derivative. So to find the derivative of x to the 1/3, you can use the power rule for that. You can just say f prime of x is equal to, well, using the power rule, that 1/3 comes down times x, and you raise it to the power of 1/3 minus 1. So you're going to x to the minus 2/3. And if you want to then rewrite that in whatever standard notation, you can do something like 1/3 times, well, if you want to get rid of the negative sign, you bring it down to the denominator, and you could do cubed root of x and then squared. That's another way of writing x to the 2/3. So that's the derivative, and you can plug in 8 to that. So f prime of 8 is that's our f prime of a. That's that right there. And I'm just substituting in 8 for x, so I get 1/3. The cubed root of 8 is 2. 2 times 2 times 2 equals 8. And then square that. 2 squared is equal to 4, so this is 1/12. And so I just want to calculate 1/12 times delta x. That's 1/12 times 1/10. That's 1/120. And I'll confess that before the video started, I plugged that into my calculator and looked up a decimal form, and I got 0.00. 0.0083. So what's this telling me now is that if I want to look at delta f, if I want to look at f of 8.1, that's the cubed root of 8.1, minus 2, that's approximately equal to 0.0083. And now bringing that 2 to the other side, that's telling me that the cubed root of 8.1 is approximately equal to 2.0083. And I looked this up, or I plugged it into my calculator, what's the cubed root of 8.1, and the first 4 digits after the decimal place were 0083. So the error, the difference between the actual value and the approximate value, that error has to be less than 1 over 10,000 because of these first, tenths, hundredths, thousandths, 10,000ths place. These first 4 digits did match. So in this case, the linear approximation using the tangent line gave us a very good approximation to the actual value of the cubed root of 8.1. That's something that would be so difficult to do in your head. I think it's just really neat that we can do this with calculus, with just pen and paper, finding some answers like that.